So for today's video, I just want to briefly cover the idea of converses. This is the first time we've maybe sort of seen this word, converse, right? And the way I really want you to think about converse, okay, it does sound like reverse, and it is sort of just like a theorem in reverse. It's basically every theorem, right, says if one thing is true, right, if something is true, then something else must be true. Well, the converse is saying that if I know that that works one way, then it must work the other way as well. So it's basically a swap of the order of the statement. That's really what a converse is, okay? So let's think about what it means in terms of the theorems we covered in the last video. What it's saying is you've got these parallel lines. Or sorry, ready? You've got these lines. We don't know that they're parallel. We're going to use this theorem to show that they are. See, there goes me getting ahead of myself, right? So something like this is what I would mean. You have knowledge that this angle is congruent to this angle. You have that knowledge, right? Why don't we call it angle 1 and angle 2? And why don't we call these lines M and N? Right? We're saying, I don't know that they're parallel, but I'd like to know that they are. Well, the converse of the corresponding angles theorem basically allows us to say, if angle 1 is congruent to angle 2, then M must be parallel to N, right? In the last video, we were talking about, oh yeah, when you have parallel lines, the corresponding angles are congruent. Well, this allows us to go backwards. If angle 1 is congruent to angle 2, then M is parallel to N, right? All those theorems we learned in the last class, it was predicated on the idea that that the lines were parallel. And now that we know those things to be true, that those things occur when the lines are parallel, well, then we can say, working in reverse, when those things occur, when the angles are congruent, this must be occurring because these lines are parallel. And we can apply this idea to every single one of these. Right? That's the activity in class. We'd be basically saying, can you take this concept and apply it here? So for alternate interior, right, if we've got two lines and a transversal, alternate interior would be these two, right? And then it would look the same. If, again, if I called this 1 and 2 and I called the lines M and N, my actual process would look the same. If angle 1 is congruent to angle 2, then M is parallel to N. My reasoning would this time be the alternate interior converse instead of the corresponding converse. So we can apply this again to alternate exterior angles. For consecutive interior, you would have to be careful because with consecutive interior, do you need them to be the same as each other? No, you need them to add up to 180 degrees. So this time it would look like we've got the lines, right? And this time it would be not about them being the same. They wouldn't be the same. But I would be able to say if angle 1 plus angle 2, if I know that they're supplementary, if they add up to 180 degrees, then the lines are parallel. Now the last thing we'll talk about is the transitive property of parallel lines. Transitive property, this pops up in other instances throughout math when we talk about exponents and multiplication, addition, subtraction. Well, it applies as well with lines. Basically what it says is if I have A, B, and C, and I tell you that C is parallel to B, and I tell you that A is parallel to B. If two lines, right, C and A, are both parallel to the same line, B, well then they must be parallel to each other, right? They must be parallel to each other. Okay. And those are our concepts for today. I want to take a look at what these look like as a problem. Right? As a problem, I can now say, is there enough information here for you to say if this is parallel or not? So I could look at number 2, right, and say 60 and 60, those are alternate interior and they're congruent. So yes, the reason why, the alternate interior converse says that if alternate interior are the same, well then P and Q must be parallel. And then I would look down here and say, it's awesome that I have vertical angles here, but vertical angles doesn't determine that they're parallel. So I'd say, no, I don't have enough info. Right? And then other new types of problems like this, find the value of x that makes it so they're parallel. So what value would I have to plug in here so I know it's parallel? Well, this would have to be 40 because that's the only way these would be the same. And these must be the same in order for m and n to be parallel. So if I wanted to do one really quick, right? Looking at a problem like this, I would have to say, all right, well, I need these alternate interior to be the same for it to be parallel. So I need x to be equal to 2x minus 95. I'll subtract 2x from both sides and get negative x equals negative 95. If negative x is negative 95, then positive x is positive 95. And that bell comes just in time for me to end this video. All right. And that's as far as we are going to get before we have our quiz, our first quiz of this chapter. So make sure you're rewatching those 3 most recent videos in preparation.